Good morning. Today we're going to talk about dilations. This is our final transformation type. So what we're going to do is I'm going to think about the word dilation. I'm going to think about something that maybe dilates. So the first thing that comes to my mind is I'm thinking of your eyes. When my eyes are dilated, say I have glasses and I need to go to the eye doctor, my eyes dilate, that means my pupils are getting much bigger. So my pupils are getting bigger. And then once the dilation starts to go away, they eventually reduce in size, and so they get smaller. So a dilation is something that is changing in size. So it's something that's getting bigger or smaller. So what is a dilation? I know it's going to be a change in size. So my shape is going to change in size, but it's not going to change the shape. So if I start with a triangle, my dilation will simply be a bigger triangle. I will not go from a triangle to a square. This will not happen. Okay, so when I have a dilation, it's a change in size, but not a change in that shape. One key thing is this is not isometric. So when we talked about isometry, we talked about translations where I slid the figure over, a reflection where I flipped it, and a rotation where I just turned it. But in the end, it was always the same shape and the same size. Well, dilation is the only transformation we're going to talk about that's not isometric. So what are some general characteristics? The pre-image and the image are similar. I'm not sure if you're familiar with this vocabulary, but you will become familiar with it as we move on in geometry. But similar means that the sides are proportional. So when the sides are proportional, that means they're growing at the same amount. Again, similar also means they still have the same shape. And it also means that the angles inside that shape are going to be congruent. So we'll talk more about similarity when we start Module 5, but just be aware that my pre-image and my image are going to be similar. They're going to be the same shape, but not the same size. But each side will grow by the same amount. So when I think about how much this is growing or shrinking by, this is called my scale factor. So how much bigger or how much smaller my shape is getting. And finally, and the last point we have here, we are always going to dilate around the origin 0, 0. So if they don't say dilate around the origin, I'm going to know that that's what I'm doing. Most importantly, when we talk about these characteristics are scale factors. So this is where I'm going to take my image length. So I'm going to take my A prime number, and I'm going to put it over A, because my image is what's resulted, and my pre-image is before, right? So this is before, and this is the after. So when I have a scale factor, I'm going to take my image and put it over my pre-image. That means if I'm looking at a scale factor that's greater than 1, for example, maybe something like 2, 7, or 3 halves. I think about 3 halves if I simplify that as a decimal, that's going to give me 1.5. 1.5 is still bigger than 1. This scale factor means my shape is getting bigger, okay? And I'm going to call this an enlargement. So anytime I have a scale factor that's some number, any number greater than 1, this is going to make my figure bigger. If I have a scale factor that is less than 1, this is going to make my figure smaller. So I'm going to call this a reduction. So an example of a scale factor that is a reduction would be half, 1/4, maybe 2/3, things of that nature. Any number less than 1 can be a scale factor of a reduction. So I'm going to look at these two final figures, and I need to first identify my image and my pre-image. So I'm looking at this first figure, so I'm looking at number 1, and I'm looking at for my pre-image, and I notice it is this black shape. This is my pre-image. That means my image is going to be this blue shape, and I know that because the blue shape has primes. It has B prime, A prime, C prime, and D prime. So I know this blue shape is my image. So if I start at my pre-image, which is this blue one, this black one, sorry, The black one is my pre-image. And I'm moving to my image, which is the blue one. I'm going to recognize that this will be an enlargement. I don't know the scale factor for this one because they don't give me any numbers, but I know for a fact that this will be an enlargement. I look at my second one. I need to identify which one is my pre-image, which one is my image. Well, I recognize that E, F, G, and H have no primes. That means this black figure is my pre-image. And I notice this blue one has the little primes on each point. So G prime, H prime, E prime, and F prime. This will be my image. So if I start at my pre-image and it is large, and I result in a smaller figure, which is my image, this would be called a reduction. So this is what I'm looking at. I'm looking at either 1, an enlargement, or 2, a reduction. And I will always have one of these two things. So let's look at our first example. I'm looking to find the scale factor. So I'm going to look at this figure to begin with and think, what do I recognize? Which one's my image? Which one is my pre-image? So I'm looking and I notice that X, R, and T, this black figure, has no primes. This tells me it is my pre-image. This is telling me I'm starting at this figure. And then I'm resulting in this big one. So this big figure is my image because I have X prime, R prime, and T prime. So I'm going to notice right off the bat that I've got from a pre-image to my image, I'm going from small to big. This is telling me I'm looking for an enlargement. When I think enlargement, I think my scale factor is automatically going to be greater than number 1. So if I get something that's less than 1, I know I've made a mistake. So I'm going to think about how I find scale factor, so I'm going to refer back, and I'm going to remember that I'm going to put my image over my pre-image length. So if I put my image over my pre-image, this should result in my scale factor. So I'm going to look and figure out which side lengths should be proportional. So I'm going to notice that X prime to T prime has a number, it has a length, it's 12. So X prime to T prime, I can find. And what side is going to be proportional to X prime to T prime? You guessed it, XT. So my image is X prime, T prime, and my pre-image is XT. So I'm going to fill in what I know these lengths are. So I know for a fact that X prime, T prime is 12. How do I know that? Because they told me. And then I know for a fact that X and T is 4. So this should tell me my scale factor should be 12 over 4. So if I simplify my scale factor, 12 over 4 simplifies to 3. So I have found my scale factor. Now if I want to check myself, I notice that they've given other lengths here. I also know the length of R prime and X prime. And I also know X and R. So I'm going to double check myself and make sure I still find my scale factor to be 3. So I'm going to take my image, which is X prime, R prime, and over my pre-image, which is X, R. This will result in 6 from this number right here over 2, which will also simplify to, you guessed it, 3. So my final answer for this problem will be my scale factor of these two triangles is 3. I notice it was an enlargement. Is my number greater than 1? Yes. This is my answer. Then I found my scale factor and shape on my pre-image and image off the coordinate plane. I'm going to try one on the coordinate plane. So this is where people's initial reaction is, I don't know how to do this. So there is a rule and we will find it after we look at this problem. So again, I'm looking for the scale factor. So I'm starting with my pre-image. So I'm going to remember my pre-image is going to be all these coordinates that do not have prime on them. So J, K, M, and L, this whole column is my pre-image. And I'm going to look at my shape and I'm going to recognize that this black shape is my pre-image, which means my primes, or my images, are this blue shape. So J prime, K prime, and N prime, and L prime. This means that this blue shape is my image. I'm recognizing that I'm going from a large figure to a smaller figure. So this specific example should be a reduction. So I'm going to think specifically my scale factor has to be some number less than 1. So if I get a number that's 2 or 4, I'm going to think, I made a mistake. Maybe I put my pre-image over my image instead of image over pre-image. So scale factor, I need to take image and put it over my pre-image. So first I need to figure out, okay, so I've listed the coordinates for J, K, M, and L. I need to find the coordinates for J prime. So I'm going to look, and I've got a location right here. And I know that this is at 0, 1. So I'm going to look at the relationship between J and J prime. So I went from 0, 2 to 0, 1. Interesting. I'm starting to notice a pattern. I don't know about you. I'm going to now look at K prime, and it's this location right here. So I'm going to recognize I go over 3. I don't go up any, so this should be 3, 0. So K started at 6, 0. K prime is 3, 0. All right, this is looking suspicious. M is at location -1, -1, because I went over 1, down 1. I started at -2, -2. Now I'm at -1, -1. Now I'm really seeing something. L prime is located at 3, -2. I started at 6, -4. I went to 3, -2. So hopefully what you're recognizing is what I'm seeing. So if I look at my image over my pre-image, I start with my image. I'm looking at 0 over 2, and I'm getting my pre-image. I'm sorry, I'm starting with my pre-image, 0, 2, and I'm resulting in my image. So if I try and find the scale factor here, I can pick any one of these points. I could say, okay, let's look at L to L prime. Sorry, I don't know why I wrote prime there. L to L prime. And I want to look at the x coordinates. I'm looking at x coordinate and the x coordinate here. So if I set up my scale factor, I just randomly picked L and L prime. Okay, so I recognize, remember, my scale factor is image over pre-image. See, it's really easy to make this mistake. So I notice my image over my pre-image. So I need to take L prime and put this on top. And then my pre-image coordinate, which is 6. I'm going to put 6 on top. So I'm going to notice my scale factor becomes 1/2. And I'm going to check myself and look at all these other coordinates. And I'm going to think, okay, if I went from 0 to 0, is 0 times 0, 0 times half 0? Yeah, it still is. What if I take half of 2? Do I get 1? I sure do. What if I take half of 6? Do I get 3? Yep. What if I take half of 2? Half of a -2, do I get -1? Yes. Half of a -2, do I get -1? Yes. Half of -4, do I get -2? Yes. So what I'm going to do here, when I find this rule, I'm going from my pre-image to my image. What's going to happen is I'm going to take my scale factor and multiply it by both coordinates. So in this specific situation, I take 1/2 and I multiply it by each coordinate. So I recognize here that I've got 1/2 x and 1/2 y. Problem I notice, it's a little bit different. They want me to graph my image. So this is going to tell me I'm going to be given a scale factor. So I'm going to look and they tell me my scale factor is 2. So I'm no longer finding it, I'm implementing it. So this means I need to use my rule. So every single time I have a scale factor, I'm going to think about my x and y coordinate multiplying by that scale factor. So here in this situation, my scale factor is 2. My scale factor is 2. So what I'm going to do is I'm going to take every single coordinate and multiply it by 2. So I want you to try that out. Pause your video and try that out. This here is that I took my coordinates and I multiplied each one of them by 2. This gave me, for my specific shape, it gave me k from -4, 4, gave me -8, 8, -4, -4, -8, -8, etc., etc. This is. So what I'm noticing here is I have now this red shape I would call my image. So I know this red shape is now my image because it's labeled with primes, and I also dilated it. So I notice that this specific, this is N prime and N prime. This specific image has become an enlargement. I know this is an enlargement because I can see that it's gotten bigger. And I also know that it's an enlargement because my scale factor was greater than 2. Okay, so I know this is an enlargement because my scale factor was greater than 1. It was actually 2. And that makes my image bigger. So at this point in the video, what I want you to do is I want you to pause it and I want you to try the next one on your own. I want to see how you do with creating your own problem. I want you to see if you can solve the next one on your own. Look at what I've done here, and I've noticed already right off the bat that because I'm graphing this quadrilateral, my scale factor is 1/5. I know automatically this is going to be a reduction, right? Because my scale factor is less than 1. My scale factor is actually 1/5. So when I know my scale factor is 1/5, what I'm going to do is I'm going to take this and plug it into my equation. I know every time I have a scale factor, I'm going to multiply both my x and my y by that. So when I take 1/5 and multiply it by -5, this actually gives me -1. And when I take 10 times 1/5, this is going to give me 2. Now, if you're unsure about that, go ahead and plug it into your calculator. But my knowledge of fractions tells me I multiply across. This will give me -5/5, which I know simplifies to -1. And this one, if I multiply across, 10 times 1 is 10, 5 times 1 is 5. This gives me 2. And so this is where I'm getting my coordinates. So I'm going to erase this just so I have space to show you my image. So I'm going to notice that my G, which starts way up here, I'm taking 1/5 of it, so it's getting far, far smaller. My G prime is going to be -1, +2. So I'm going to graph it here. Here's G prime. Notice how I'm labeling it. F to F prime, -1 to -2, I to I prime. Remember, anytime I multiply something by 0, I'm just going to get 0, so it's going to stay 0, but 1/5 of 10 is going to be -2, and then 1/5 of 5, just like H, H prime is going to be -1. So I've graphed my points, I've plotted them, and I've connected them, and even though this is at a much smaller scale, I can tell that this is clearly the same shape, just a different size. So I still have the same shape, but a different size. This is, by definition, a dilation. So what I want you to do now is I want you to grab your other sheet that you picked up on your way in. You have problems 1 through 4, and I want you to do the exact same thing. I want you to identify the scale factor. Multiply your coordinates by that scale factor. So a lot of times they're not going to give you the original coordinates. You're going to have to find them. So I want you to find those coordinates and then dilate them by whatever percentage they need to be dilated by. Once you're done with that, go back on the canvas, and I've got a couple other things for you to do.